Hello Math 1, I'm back with a new chapter. We're still going remote, but I think you guys will find this one maybe a little less frustrating than what you saw with chapter 4. We're going to be continuing with the idea of graphing linear equations, but instead of you having to come up with the equation and graph the situation with different variables, it's going to be just straight up x and y are given to you in an equation format. So, last chapter, what we did was we basically had to come up with a scenario of y equals, and we called it always had a starting point, and we were either adding to or subtracting from some kind of rate of change that was either increasing the starting point for plus or decreasing the starting point for minus. And we always multiplied that rate of change times our x variable. So you'll probably see on this paper a bunch of equations that's given to you, and the idea is, what are we supposed to make of this? Well, here's the interesting part. The starting point is, if y is by itself, the starting point is always going to represent a very particular part of the graph. It's always going to represent the place where it crosses the y-axis. So we call that the y-intercept, okay? So right now, the starting point, we're going to rewrite it as the y-intercept, the place where it crosses the y-axis, all right? And we're actually going to call that the variable b. All right, now the origin of that variable is actually something called, I can't remember what it is, but it basically writes the equation in terms of the x-intercept and the y-intercept. The y-intercept is given in b in that equation. All right, so b represents the starting point. Our rate of change is going to be written as the rise over run, also known as the slope. And we talked about that just a very little at the very beginning of last chapter, about 3 weeks ago. And we said that would be m, probably from the French word monter, which means to climb. So what we can do is we can just say plus m, so that if it is a negative slope, then that will just be like a plus negative something. And then multiply that by x. So every single equation should have this kind of structure to it, where you get one starting point number, one number that alters the rise over run. So what is slope-intercept form? Slope-intercept form is just a slight variation of what we already did last chapter. What we did last chapter could be rewritten to look like this. Slope-intercept form, all it does is says the commutative property states that you can flip these two amounts around. So y equals the slope plus the y-intercept. And we're basically going to use this to graph every single situation you see on 5.1. So, maybe it'll be easier if we just dive into this, yeah? So checking out some of the examples we see in front of us. Our job is going to be to take this y equals mx plus b format, this formula. All right, so every single time we're thinking to ourselves, all right, this is the structure. I can get points from here, and I can get points from there. So you see y equals 5 minus 2/3 x. If we were to rewrite that in slope-intercept form, just to kind of get a feel for this, we would say this is the same as y equals negative 2/3 x plus 5. Which means we have a starting point or a y-intercept of b equals positive 5. So that means that we're going to start on the y-axis. Remember, the vertical is y every time. The horizontal is x. Start 1, 2, 3, 4, 5 units above. And then if m equals negative 2/3, what that means is that either the top is negative and the bottom is positive, or the top is positive and the bottom's negative. Basically, you can get a negative number by taking a negative divided by a positive, or a positive divided by a negative. And what that does is it tells us that your rise over run is going to be down 2, right 3. And you could plot another point, down 2, right 3. Or up 2, left 3. See, both of these versions of that rate of change, both of these versions of that rise over run, will get you points that actually exist on the line. From there, you take a straight edge. I don't know if you guys have rulers at home, but just find something that'll make a straight line. Put arrowheads on the end of that to indicate that it goes on forever in those two directions. And there's number 1. This is what it looks like in slope-intercept form. This is the slope, here's the y-intercept, and here's 4 points that I plotted on that line. Let's check out number 2. Number 2 is already in slope-intercept form, y equals mx plus b. So m is equal to positive 4 over positive 3. All right, that's good. Good to know. Our b, our y-intercept, notice it's minus 6. All right, so we're going to put a negative 6 as our starting point. B equals negative 6. So start at the origin. Here's our y-axis. Here's our x-axis. B means go down 1, 2, 3, 4, 5, 6. Plot a point at negative 6 on the y-axis. Then you're going to travel up 4 units. 1, 2, 3, 4. And then right 3 units. 1, 2, 3. Up 1, 2, 3, 4 units, right 1, 2, 3. And it looks like we can probably only plot those 3 points on the graph. We can't really go in the opposite direction too far. I don't know if you guys can see that, but we're kind of out of room. So then we can connect those dots. Put arrowheads on the end to indicate that it has forever type behavior. And you're done. So far, pretty simple. Why don't you guys try number 3 on your own? All right. So hopefully you guys paused that video. You rewrote it as y equals mx plus b. So this is y equals 4x plus 2. Furthermore, I would hope that you guys would think of this as a fraction because it's a rate of change, it's a rise over run. So put 4 as 4 over 1. So the slope is going to be m equals positive 4 over positive 1. Our y-intercept is going to be b equals 2. Here's our y-axis, here's our x. Start at positive 2 on the y-axis, that's 2 units above the origin. Then go up 1, 2, 3, 4, right 1. Now, I don't know if you guys thought of this, but up 4, right 1 is going to be the exact same thing as down 4, left 1, right? If I go down 4, left 1, I've got another point that is a continuation of that line. It keeps the line moving. So I can go in the opposite direction, 1, 2, 3, 4, left 1, and get the same points that I would plot if I did up 4, right 1. So every slope, every rise over run really has 2 different identities. And these are the 2 ones for this. All right, number 4. This one always is tricky for students at first. They look at the 2 fractions and they think to themselves, okay, so am I supposed to have 2 rise over runs? Not so. You should rewrite this as y equals mx plus b. So it's going to be positive 3/4 x minus 4/5. And all this means, y-axis, x-axis, is that, yeah, our slope is going to be positive 3/4, or like we just talked about over here, negative 3 over negative 4. Hopefully I made that clear enough. Let me rewrite this. Ugh. So it's either positive 3/4 or it's negative 3 over negative 4. Now, the b value means, the b value at negative 4/5, all that means is that we're going to start 4/5 of a block below the x-axis. So here's one block. 4/5 of a block is going to be just above that. Okay? It's not go down 4, right 5, and then plot a point. A lot of students like to do that. It doesn't work that way. It's got to be a place where it crosses the y-axis. And that's the place where it crosses the y-axis. All right? So our starting point is a fraction. It's a decimal. It's negative 0.8, or negative 4/5 of a block. From that fraction block, you're now going to go up 1, 2, 3. Now notice I'm right here. I'm not right on a whole number grid value. I'm still a little bit above the 2 block here. So up 1, 2, 3, right 1, 2, 3, 4. So notice I plotted the point at another fractional spot in between grid blocks. And then I'm going to do the same thing in the opposite direction. Down 1, 2, 3, left 1, 2, 3, 4. At this point, I'm going to connect my dots, and I'm done. All right, so one more graphing example. I wanted to throw this out at you. What happens if one of our equations doesn't have what seems to be like completeness to it? Y equals mx plus b is what we're looking for. It looks like we've got y equals mx, but no b. Well, if you're left with no b, all that means is that there's an imaginary plus 0 that's tagged along here. That plus 0 means, oh, we're starting right at the origin. The origin is literally a point on that line. Okay? So that's the place on the y-axis where we start. Again, the slope is going to be a negative number, so you can either get a negative number by taking a negative divided by a positive, or taking a positive divided by a negative. So we can go down 1, right 1, 2, 3, 4, or we can go up 1, left 1, 2, 3, 4. And those are both legitimate points using two different rates of change. Or rather, two versions of the same rate of change. And there we are. So that's all I'm going to talk about for graphing. On the back side, I wanted to show you guys a little bit of what it means to work backwards. So if you scroll down to the next page of notes, these examples won't take as long. So how are we supposed to write the equation if we're given the graph? Well, remember, we're working from this y equals mx plus b model every single time. So all you guys need to do is figure out, well, what's my starting point? And what's my rise over run? When I do that, I just fill in the information. And you put it on this line down here. So where's my starting point on number 6? Well, the starting point is always the place where it crosses the y-axis up 1, 2, 3 units, b equals positive 3. So what that means is that right here, I'm erasing plus b and putting plus 3. All right? Now, to find my m, I'm looking at the rate at which it changes from one point to another. So it looks like I got a point here and a point here. I've got to travel down 1, 2, 3, 4 vertical units. So minus 4, and then write 1, 2, 3 horizontal units. So that would be plus 3. So based on this down 4, right 3, my m is going to be negative 4 over positive 3. So I'm going to take away the m, and I'm going to put in place, let's see, a negative divided by a positive is a negative number, so it's negative 4/3. And there it is. Y equals negative 4/3 x plus 3. Pause the video and try this one on your own. All right, let's see if you guys did it. This would be our starting point, which is our b value on the y-axis. It starts 1, 2, 3, 4, 5 units below the y-axis, so you have a negative 5. So you're erasing plus b, replacing it with minus 5. What's my slope? Well, I have to move from this point to this point up 1, 2, 3. So that's a plus 3. Right 1, plus 1. So my m is going to be plus 3 over plus 1, which is the same as just 3, okay? So 3 divided by 1 is 3. So I'd replace it with 3x minus 5. All right. Now pause the video and try the last one on your own too. All right, let's see if you guys got it. Looks like the b value is the origin, so b equals 0. So you got two options here. You can either just erase the plus b altogether and say there is no plus b, or if you want to play it safe, you could say, all right, the b's gone. I'm going to put a 0 in its place. Okay? So there's the b. It looks like I plotted a point right here. So the m is going to be down 1, 2, 3 units. So down 3, and then right 1, 2, 3, 4, 5, 6. Now, if m is equal to negative 3 over positive 6, what you guys should do is before you write it in the equation, reduce the fraction if you can. Negative 3 over positive 6 is negative 1/2. So that's the version of m that we want to put on our paper. So get rid of b, you get 0. Get rid of m, you put in place negative 1/2 x. So our answer could be y equals negative 1/2 x plus 0, or just leave it like that. All right, guys, thanks for watching. I know this is a little bit longer of a video, but I wanted to make sure I was very clear on exactly how to do this. Thanks for watching.